Welcome to finintro. What we're going to do in this particular video is look at how we create present value by discounting future streams. So this is one investment, and instead of having just one simple lump sum come back to us, we're going to look at how multiple streams are going to come in. We make one investment, we make $4,000, then $8,000, then $5,000, then $4,000, then $3,000 each of the years consecutively after that. And the way we're going to do this is by breaking them up into, let me make sure I'm on green here, into separate present value equations. So we're going to take this one and we're going to bring it back, then we're going to take this one and we're going to bring them back. And we're going to do that one at a time for each one. So let's begin with the 4,000. And in order to bring it back, what I need to do is discount this 4,000. Remember, our present value equation looks like whatever the future value is divided by 1 plus r to the n. So I'm going to do the same thing here. I'm going to divide by, and let's come up with a percentage rate. Whatever I is going to be equal to, let's say, 12%. Okay? Doesn't really matter. Oh, wait, it does matter because I'll be doing the, what is the percentage rate that we're doing in the book here? 9%. All right, it does matter. So I will be doing, I'm in the book. I'm in the Intro to Corporate Finance, Graham and Smart, Abridged Edition, and I am in Chapter 3, and I'm doing Figure 310. So you can follow along with me and do Figure 310, okay? So we're going to do this interest rate at 9% and see what these guys look like. This dude, 4,000, if I discount him, I divide by my, as if I'm calculating one present value at a time. So that's going to be 1 plus 0.09 to the first, because it's only 1 year. And I'm going to discount that. I'm going to just bring it down here to make it a little cleaner. Let me scroll up and out of the way here so we have more space. I'm going to scroll it back. And this turns into 3,669.73. Okay? And so that's just one simple present value equation. But then I'm going to do the same thing for this 8,000. And what's the difference here? The difference here, so I'm doing it at the same rate. The difference here is that instead of doing it for 1 year, I'm going to do it for 2 years, as if it's a lump sum that gets paid in 2 years. And the same thing, I bring it back out to 67, or bring it back down to the present, to time period 0, and I get 67.33.44. Do the same thing for the 5,000 in year 3, actually. I'm going to do the same thing for the 5,000 in year 3. I'm going to divide by 1 plus 0.09. But this time, instead of, because I'm 3 years out from the present, I turn that into a 3, and I discount it back to, or at, it becomes 38.60.92. You'll notice that I'm not doing the calculator here. I'm talking about this conceptually. You guys should already be able to calculate lump sums of present values by now. So again, I divide by my time value modification, and it's 4 years out. So I bring it down and across 4 years. And this is, in the fourth year, 28.33.70. And finally, I do my fifth year, which looks like this. It's a long time coming back. So it's going to be 1949.79. Nothing here should be really surprising, just the fact that all of these happen independently. So you're going to do one, and then the other, and then the other, and then the other, and finally the last one. You know what? We'll take the time to write it up here correctly. Pencil, please. 1 plus 0.09 to the fifth. And when I add all of these up, so I discount all these and it comes back, and then it comes back, and then it comes back. And so now every single one of these cash flows, 4,000, 8,000, 5,000, 4,000, 3,000, has been discounted to time period 0. So these are basically all at the value of their future cash flows in the present, hence the present value. And when I add them all up, they become 19,000 0.4758. Again, this is figure 3.10 in the textbook. 3.10 in the textbook. So that's basically it. When you discount these back, you're going to do them one at a time, and one at a time, and one at a time, and one at a time. The equation for this looks a little complicated. Okay, my present value is equal to whatever it is in the first period. Okay, usually we do future value over 1 plus r to the n, but here we're not calling this future value because it's not just one value. So instead of doing future value, I'm going to call it the cash flow in period 1. And because I know this is the cash flow in period 1, I also don't really need my n. I need whatever the period 1 is, because I know it's going to be that one. Then when I discount that one back, I look at my second cash flow period. 2, 1 plus r squared, because it's period 2, and so on, dot, 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 until I get to the last one. So this is going to be cash flow in period t, which just basically means the last one in the series. 1 plus r to the t. So this is what you might see in the book, or something just like it. You might see cash flow times 1 over 1 plus r to the 1, etc. You might see something like this, but it's the same thing mathematically. Don't get confused and don't think too much about it. Just understand that all we're doing with this equation, with this mixed streams, is taking our cash flow and discounting it back to the present. We take our cash flow, we discount it back to the present, we add them all up, and we come up with our present value. There is a simple way to do this on your calculator, and I'll be doing that in the calculator problems, but this is a great practice. Do this one first, and then we'll do the calculator separately. Good luck.